Hello students, I welcome you in today's session of physics, and in physics I am going to present you chapter number 12, which is known as the reflection of light at a plane surface. You can see here, this is the chapter we have to discuss. So first, before going to start this chapter, just have a look what does this syllabus. So in this syllabus we have to study about the reflection of light, image formed by a plane mirror, regular and irregular reflections, image formed by a pair of parallel and perpendicular plane mirrors, simple periscope. This is the syllabus. So first we will start with the laws of reflection and the formation of image by a plane mirror. Clear? So here you can see the first topic is the 12.1, so which is your reflection of light. This one. So what is the reflection of light? When a beam of light is incident on a surface, a part of it is returned into the same medium. Clear? So the part of a light which is returned into the same medium is called the reflected light. So you can say that the return of a light into the same medium after striking a surface is known as reflection. Fine. So the remaining part of light which is either absorbed in the surface on which the incident light is strike is opaque, or it is partially transmitted and partially absorbed if the surface is transparent. So it is the reflection of light which enable us to see the different objects around us. So an object is seen when the light from it enter our eyes. The luminous bodies when emit light by themselves are directly seen, but the non-luminous objects which do not emit light by themselves are seen only when they reflect the light incident on them. Clear? So the reflected light on entering into our eyes make them visible. Now different surfaces reflect light to different extents. So highly polished and smooth surfaces such as plane mirror reflect almost the entire light falling on it. Clear? Now a plane mirror is made of a few millimeters thick glass plates. So one surface of the glass plate is polished to a high degree of smoothness, which form the front surface of the mirror, and the other back surface is silver, that is painted with a silver, mercury or some other material. So the silver surface is further coated with some opaque material so as to protect the silvering on the surface. So these surfaces of the plane mirror are shown in the figure. Here you can see that. So light enters from the side of polished surfaces being smooth and does not diffuse light and is strongly reflected from the silver surface. So the coating serves as an opaque surfaces and it does not reflect the light. Here you can see that this is the coating silver surface this side, and this one is the reflecting surface. Now we discuss about what are the kinds of reflection. So there are usually two kinds of reflection. The first one is the regular reflection and the second one is the irregular reflection. So what is the regular reflection? So regular reflection occurs when a beam of light falls on a smooth and polished surface such as a plane mirror. Here you can see in this figure, this is the plane mirror and this is your rough surface. Fine. So in the figure 12.2 you can see here a parallel beam of light is incident on a plane mirror. The reflected beam is also parallel it and it is in a fixed direction. This is called the regular reflection. Fine. Here you can see this. Now come to the irregular reflection. If we talk about, so irregular reflection occurs when a beam of light fall on a rough surfaces such as wave of walls of a room, page of a book or any other object. The wall of a room or a page of a book may appear smooth, but if it is examined under a microscope it appears quite uneven, having many small projection over it. Fine. So when light rays strike different parts of a rough surface, such rays gets reflected from the different points of the rough surface and obeying the laws of reflection of light. Now due to uneven surfaces, the light ray get reflected in different directions and give rise to adjusted or irregular reflections. Clear? So figure 12.2 I will show you already this figure, this one, the two figures. Now this figure shows the irregular reflection from a rough surfaces. It is overall light that is diffused. Now the reflected light now is spread over a wide area and it does not follow a particular direction as it does in case of the regular reflection. So it is the diffuse light obtained by reflection from the uneven surfaces which enable us to see the object around us. Now here are the some terms which are related with the reflection. The first one is the incident ray. So the light ray which is striking the reflecting surface is called the incident ray. Clear? The point of incidence, the point at which the incident ray strikes the reflecting surface is called the point of incidence. The third one is the reflected ray. The light ray obtained after reflection from the surface in the same medium. Clear? Which the incident ray is traveling is called the reflected ray. The fourth one is the normal. The perpendicular drawn to the surface at the point of incidence is called the normal. Clear? Now see the fifth one. What is the angle of incidence? So the angle which the incident ray make with the normal at the point of incidence is called the angle of incidence, and it is denoted by a small letter I. What is the angle of reflection? So the angle which the reflected ray make with the normal at the point of incidence is called the angle of reflection, and it is denoted by letter small r. Now see the seventh one, the plane of incidence. So the plane containing the incident ray and the normal is called the plane of incidence. Fine. Now the seventh and eighth one is the plane of reflection. So the plane containing the reflected ray and the normal is called the plane of reflection. Fine. Here you can see the figure, this one. The mm1 is your reflecting surface. Clear? Is a plane reflecting surface. You can say the plane mirror kept perpendicular to the plane of paper. Now the light ray is incident in the direction OA at a point O. Here you can see this is the incident over a point O. This is the point of incidence, this is the incident ray, this is the reflected ray, and the normal. So all these three rays are lying on the same point, and this point is called the point of incidence. Clear? So that is the thing written here. Now what is the laws of reflection? So the reflection at a surface obeys the following two laws, which are called the laws of reflection. The first one is the angle of incidence, that is I, is equal to the angle of reflection. So we can write it angle I equals to angle R. Clear? Here you can see the figure number 12.4. So for an incident ray normally on a surface, angle of incidence which is I equals to 0 degree, therefore the angle of reflection, that is R equals to 0. So thus a ray of light AO incident normally on a surface is reflected along the same path, as you can see from this figure. So this is the first law. Now we will discuss about the second law of reflection. So this is the second one. The incident ray, the reflected ray, and the normal at the point of incidence lie in the same plane. Clear? I hope you understood. Now we will discuss about the experimental verification of the laws of reflection. So the laws of reflection can be verified by the following experiments. Now I am not going to discuss about the experiments. Here you can see this is the experiments, and we measure the different angle. For the angle of incidence, the angle of refraction. Clear? I am taking your from here the formation of image by reflection. What kind of images form when the reflection takes place? So from each point of illuminated object, rays of light travel in all the directions. So we need to consider at least two rays of light from a point of object or incident on the mirror. So they get reflected obeying the laws of reflection. So the point where the reflected ray of the light actually meet, or they meet when the produced backward, gives the position of image at the point of object. So thus we can obtain position of image of different points of object, by joining which complete images of object can be obtained. So the image can be of two types. The first one is the real one, and the second one is the virtual one. Now we will discuss what is the real image and what is the virtual image. So the first we talk about the real image. So the image which can be obtained on a screen is called a real image, and it is formed when the light rays after reflection actually intersect. It is inverted. For example, for a distant object, the image formed by the concave mirror is real. Now see the second one. What is the virtual image? So the image which cannot be obtained on a screen is called the virtual image, and it is formed when the light rays after reflection do not actually intersect, but they appears to diverge from the image. So geometrically, they intersect when they are produced backward, it is erect. For example, the image formed by the plane mirror at a convex mirror is virtual. There is the distinction between the real and the virtual image. What is real image and what is the virtual image? So a real image is formed due to the actual intersection of the reflected rays. A virtual image is formed when the reflected rays meet if they produce backward. Now see the second one. A real image can be obtained on the screen while the virtual image cannot be obtained on the screen. Now see the third one. A real image is inverted with respect to the object, and the third one is the real virtual image is erect with respect to the object. Now here are the examples given here. The image of a distant object formed by the concave mirror, and the image of an object formed by a plane mirror or a convex mirror. Fine. Now here you can see the image form a point object which is formed by a plane mirror. So in this figure you can easily understood what's going on. This is the figure 12.6. We are supposing here dash be a plane mirror in front of which an point object O is placed. So from the object O, ray of light travel in all the directions. To show the formation of image by plane mirror, we need at least two rays from the point of object O, and which fall on the mirror MM1. This is the mirror MM1. Let us suppose OA and OB be the two rays which are incident on the plane mirror from the point objects O. So the ray OA and OB, obeying the laws of reflection, get reflected from the mirror MM1 in the direction AC and BD respectively. Clear? Such that angle CAN1 is equals to angle OAN1 and angle DBN2 is equals to angle OBN2. So here angle AN1 and BN2 are the normals at the points A and B respectively. Clear? So when seen from a position between C and D, the rays AC and BD appears to come from the source point I behind the mirror. So the point I is the virtual image of the object O, and the image is virtual because the reflected rays, which is your AC and BD, do not actually meet at I, but to our eye they appears to come from the point I. So to locate the position of I, the reflected ray AC and BD are produced backward, and the point where they meet gives the position of I. Clear? So how can we find out the position of I? Here you can see this is given here, position of image. So the image I is as far behind the mirror of the object O is in front of it. That is, the perpendicular distance of image from the mirror is equal to the perpendicular distance of the object from the mirror. Clear? Now this is the proof given here, so I am not discussing about the proof. You can see this is the figure and you can easily understood by this figure. If you still feel any doubt, you can ask me in the comment section, students. Clear? Now we will discuss about the image of an extended object formed by a plane mirror. This is the 12.8. So here you can see in the figure below given here, this one. This is the 12.8, and from this figure we can easily understood. Now we are supposing that the MM1 be a plane mirror in front of which an extended object, which is your AB, clear, is placed. So from all the points of the objects, light ray travel in all the direction. Now let us consider the end points A and B. Fine. So of the object, let AP and AQ be the two rays incident on mirrors from the point A of the object, which get reflected from the mirror as PP dash and QQ dash. So these reflected rays, when produced backward, they are meeting at the point A dash. So we can say that this A dash is the virtual image of the point A. Similarly, from the point B of the objects, BR and BS be the two incident rays on mirror which are reflected as RR dash and SS dash respectively, and they meet at the point B. So when produced backward, thus B dash is the virtual image of B. Similarly, for all other points of the objects AB, virtual images are formed between A dash and B dash. So thus A dash B dash is the virtual image of the object AB. It is erect and of size equal to that of the object. The normal distance of each point of image behind the mirror is same as the normal distance of the corresponding object in front of the mirror. Fine. Now we will discuss about the lateral inversion. What is the lateral inversion? You can see here, this is the important topic. So in our daily experience, while looking in a mirror, we Locate. Notice that a ring on the finger of the left hand appears to be in the finger of the right hand of our image as shown in the figure you can see here. Similarly, the pockets on the left appears to be in the right in the image. So this interchange of the left and the right sides is called the lateral inversion. Fine. So now here you come. Thus the interchange of the left and right side of the images of an object in a plane mirror is called its lateral inversion. So the lateral inversion produced by a plane mirror is similar to the inversion that occur on the blotting paper which is used to dry ink. While writing, the individual letter obtained on the blotting paper cannot be read directly, but it can be read by seeing its image in a plane mirror. So figure here you can see this is the figure which shows the image formation of a letter P in a plane mirror. So the letter P appears in a plane mirror as like this. Similarly F like this. Clear? This has only happened due to the lateral inversion. So note that the lateral inversion of the letters such as these are the letters is not noticeable since their image remains unchanged. So these are the some letters which their images after lateral inversion not change. Clear? So it is due to the lateral inversion, this is the most important example of the image formed in a plane mirror, that it becomes difficult to read the text of a page from its image formed by the reflection from a plane mirror. Therefore, the letters on the front of an ambulance are written laterally inverted like this. Now the drivers of a vehicle moving on a road ahead of the ambulance read these words laterally inverted as like ambulance. So in his rear view mirror, and so he gives sight to the pass the ambulance first. Clear? Now students, sees the characteristics of the image formed by the plane mirror. So the image formed by the plane mirror is, the first one is upright or erect, the second one is the virtual, and the third one of the same size as the object, and the fourth one is the laterally inverted. So in addition to this, the image is situated at the same perpendicular distance behind the mirror as the object is in front of it. So it is obvious that if the object is shifted by a distance small d toward the mirror, the image will also shift by the same distance d. Therefore, the mirror, that is the separation between the object and the image, will decrease by how much? 2d. Thus, if an object moves with a speed v towards or away from a mirror, the image to him will appears to move with a speed 2v towards or away. From this figure you can easily understood what I am talking about. Example, a boy standing at a distance of 5 meters away from a plane mirror. This is the figure plane mirror, and the boy standing at a distance of 5 meters. Now if he moves a distance 2 meters farther away from the mirror, his distance from the mirror will become 7 meters, and then to him his image will appear at a distance of 14 meters from him as shown in the figure. Clear? So this is the due to the lateral inversion. And now students, you can see here, I hope you understood what I taught you. And after the new lecture, in our new lecture we will discuss about the image formed in a pair of mirrors. Fine. In the above topics we will discuss about the plane mirror. Now we will, in our upcoming lecture, we will discuss about the image formed by a pair of mirrors. Fine. So till that, do study. Thank you class. Thank you very much.